Hi everyone, welcome to School Coaching Point. Today we will learn a few important questions from the topic circle from class 10. Download the PDF from the link given in the description box. Subscribe and press the bell icon for more videos. So this is the first question in front of you. A circle touches all the four sides of a quadrilateral ABCD. So this is a quadrilateral ABCD. ABCD is a quadrilateral and the circle touching the quadrilateral at the point PQRS to prove that AB plus CD equals to BC plus DA. So this is part 2. So in part 1 we have already discussed the tangent drawn from the external point to a circle are equal in length. So you can see the image. In part 1 we have already discussed tangent drawn from the external point are equal in length. So AP and AS are the tangent drawn from the external point. So there should be equal in length. So let's move to the solution. Let O be the center of the circle. Let O be the center of the circle. O is the center. ABCD is a quadrilateral. ABCD is a quadrilateral. ABCD is a quadrilateral which ABCD is a quadrilateral which touches the circle, at the point PQRS. So ABCD is a quadrilateral which touches the circle at the point P, Q, R and S respectively. ABCD is a quadrilateral which touches the circle at the point P, Q, R, S respectively. At the point P, Q, R, S. So to prove that AB plus CD is equals to BC plus DA. So we know that the tangent drawn from the external points are equal in length. We have already discussed in part 1. So from the point A, AP and AS are the two tangents drawn from the external point A to the given circle. So we know that tangent drawn from the external point tangent drawn from the external point to a circle are equal in length. So A is an external point, AP and AS are the tangent. So the length of AP and length of AC should be equal. So therefore AP equals to AS, tangent drawn from the point A. Tangent drawn from the point A. Suppose this is equation 1. Similarly, from the point B, there are two tangents BP and BQ. The length of BP and BQ also should be same according to the theorem. So BP equals to BQ. So BP equals to BQ, tangent drawn from the point B. Tangent drawn from the point B. So it is equation 2. Similarly, from the point D and C, from the point D, DR and DS are the two tangents. So DR equals to DS, tangent drawn from the point D. Tangent drawn from the point D. So give it equation 3. Similarly from C, CR and CQ are the two tangents. So CQ equals to CR. So CR equals to CQ, tangent from CR equals to CQ, tangent from the point C. So this is equation 3 and it is equation 4. So we get 4 equations, 1, 2, 3 and 4. So from previous steps, we get AP equals to AS, tangent from A, equation 1, PB equal to PQ, equation 2, DR equal to DS3 and CR equal to CQ. There are 4 equations. So to prove AB plus CD equals to BC plus DA. So now adding all these 4 equations. So adding equation 1, 2, 3 and 4. So how to add these 3 equations? One thing we should remember, the left hand side should be added to the left hand side. So in the left hand side of this equation, AP plus PB plus DR plus CR is equals to right hand side equals to the right hand side. So AS plus BQ plus DS plus CQ. AP plus PB. So AP plus PB means AB. So AP plus PB is equals to AB. Similarly, DR plus CR is equals to DC. So DR plus CR equals to DC. Now AS plus BQ. So AS and BQ are in opposite direction. So we need to arrange the term AS plus SD or DS. So AS plus DS we should write together, and BQ plus CQ we should write together. Implies AB plus DC, AS plus DS is equals to AD plus BQ plus CQ is equals to BC. BQ plus QC is equals to BC. So implies AB plus DC, you can write CD. Same, DC and CD are same. So AB plus CD is equals to BC plus DA. Hence proof. So let's move to the next question. If all the side of a parallelogram, so ABCD is a parallelogram, touch a circle. So this parallelogram touching the circle at the point PQRS, so that the parallelogram is a rhombus. So in this case, a parallelogram becomes a rhombus when all the adjacent sides are equal. So in this case, first of all, write down the given part. Let O be the center of the circle. Let O be the center of the circle. Let O be the center of the circle. ABCD is a parallelogram. ABCD is a parallelogram touching the circle at the point PQRS. Let O be the center of the circle. ABCD is a parallelogram touching the circle. Circumscribing the circle means we should draw the circle inside the parallelogram. So while you draw the circle, it touches the parallelogram at the point PQRS. So ABCD is a parallelogram circumscribing the circle. ABCD is a parallelogram circumscribing the circle, touching at the points PQRS respectively. So PQRS respectively. So these steps are exactly same as the previous question. PQRS respectively. To prove that ABCD is a rhombus. That means in this question we need to prove that adjacent side of the parallelograms are equal. When the adjacent side of the parallelograms are equal, it becomes a rhombus. So ABCD is a rhombus, we need to prove. So proof, we know that tangent drawn from the external point. So we know that tangent drawn from the external point to a circle are equal in length. We know that tangent drawn from the external point to a circle are equal in length. So we have already learned in part 1. So in the first video we have already learned this thing. So here DR and DS are the two tangents drawn from the external point D. So their length should be equal. So dr equals to ds. Dr equals to ds because these are the tangent drawn from the point D. So these are the tangent drawn from the point D. Suppose give it equation 1. So equation 1. We got dr equal to ds, tangent from the point D. Similarly, from C, CR and CQ are the two tangent. So their length should be equal. CR equals to CQ, tangent from the point C. Tangent from the point C. So give it equation 2. Exactly same way from the point A, AP and AS are the two tangent. So AP equals to AS. AP equals to AS. Tangent from the point A. Tangent drawn from the point A. Give it equation 4. So actually these steps are exactly same as the previous questions. So for you it is easy to remember the steps actually. So from the point B, BP equals to PQ, tangent from the point B, tangent drawn from the point B. So there are 4 equations. So we need to add all these 4 equations, adding 1, 2, 2, 3 and 4. So left hand side should be added to the left hand side and right hand side should be added to the right hand side. So all the left hand side should be added together. So dr plus cr plus ap plus bp is equals to ds plus cq plus as plus bq. So ds plus cq plus as plus bq. So implies dr plus cr is equals to dc. So dr plus cr equals to dc. ap plus bp is equals to ab. And ds plus as. So ds and as we should write together. ds plus as, arranging the term, cq plus bq implies dc plus ab is equals to ds plus as means ad plus cq plus bq means cp. So from this step we have already done in the previous question. So give it equation 5. So after that 2 more steps we need to write. Now ABCD is a parallelogram. So it is given. ABCD is a parallelogram. And we know that in parallelogram opposite sides are equal in length. So therefore AB should be equals to CD because these are opposite side of the parallelogram, and AD equals to BC, opposite sides of the parallelograms. We know opposite sides of parallelograms are equal in length. But DC plus AB equals to DA plus AB. From 5 we can write. So from 5. So DC plus AB equals to DA plus CB. Now since DC and AB are same, so we can replace, since DC and AB are same, so we can replace AB by DC once again. So DC plus DC. Similarly AD and BC are same, so we should replace BC by AD. So DA plus DA. So DC plus DC is twice DC equals to twice DA, implies DC equals to DA. So what is the last step? DC equals to DA. That means in this parallelogram adjacent sides are equal. And we know that in a parallelogram if adjacent sides are equal it becomes a rhombus. For a parallelogram if adjacent sides are equal then it becomes a rhombus. So a parallelogram whose adjacent sides are equal, a parallelogram whose adjacent sides are equal. So if adjacent sides are equal, so it must be a rhombus. Therefore, it is a rhombus. ABCD is a rhombus.